Alright, so for studying parabolas, we use parabolas a lot more than we think. How many of you have cell phones? You probably use a parabola every time you use your cell phone.
I use my finger.
The signal goes to a cell tower. The cell tower sends it to a satellite, which has a dish on it. It sends it to the company that has a dish on their building. Okay, so we're using paraboloids all the time, we just don't know it. So in a satellite dish, every signal that comes in here is focused where?
Right there.
Right there.
Yep.
So this is the focus of this paraboloid, right? So our parabolas are going to have a focus, and every signal, any direction it comes from, it's all going to end up in that one spot, right? So what happens when you have snow on a dish?
It doesn't work.
It doesn't work very well. Why?
You got to go outside and flip
Because the signals are bouncing all over the place, right? So it has to be clean, nice and free of interference. It'll kind of work a little bit, but with snow on it, but you kind of get the point, right? What else is a paraboloid?
What else?
Yeah.
In that?
Satellite dishes are paraboloids. Can you think of anything else? There's one in my pocket.
Talk about your glass eye. I don't know. Warm now. Told you.
How are lenses shaped?
Parabola.
They're parabolic. Now, do we want a flashlight that focuses all of the intensity in one little spot?
No. We want it dispersed.
Not necessarily, right? So they're shaped a little differently so that the light spreads. And some of these flashlights, snap on, well done. You can change the cone size. So you can move the parabola up and down on the flashlight to make it focus or spread out. Right? So we're using a little bit of math there. Thank you. Don't own this.
Oh, you took it.
Anybody in here wear glasses?
I don't.
Some of you do, right?
I don't.
They're shaped parabolically so that they, when the light comes in, it refracts into your iris, into your pupil, right? And focuses on the retina. Okay, so you've got parabolas all over the place.
Hey, we're like a picture.
A bowl, like a cereal bowl, will look like one, but it's not a perfect parabola because you need a base, right? So a perfect parabola will not balance on one little spot. But.
Okay. Okay, right. What did you get?
Okay, so parabolas can be, as we have studied, right? Or we can actually move them and study their inverses as well. Okay, could we conceivably tip one 45 degrees? Yeah, that's a whole other ball game. We won't worry about it. But so with the two, obviously, we're going to study your vertical and horizontals. Okay. Do you remember how the parent function was written for a parabola?
X squared. Yeah, why you don't
Did you say it, or was I ignoring you? What was out front? Do we have a letter out front there? To make it skinnier or wider?
Go for the parent function.
Yeah, parent function. So x minus h plus k. Remember, hk is the vertex, and a was how wide or skinny you wanted to make it, right? Okay, so we've learned to work with the parent function version of this. We're going to add a little bit to it so that we can calculate a few different things. So first thing we want to be able to calculate is the focus. Okay, right? We also want to know the vertex.
How do you like with the focus? How do you know?
All right, fine.
I was just gonna ask, like, how do you know like whatever the focus is?
Well, that's what I'm about to show you. Yeah. Okay. This here is called the directrix. Okay. It is equidistant from the vertex and the focus. The vertex is the midpoint of the focus and directrix. These are the same distance. Right? So, just note that. Okay, those are the same distance. And we can also have an axis of symmetry. Okay. Seriously, take that off the wall.
The patch.
It's an eyeball remover.
Okay, Caleb, can I bring that to my desk and put it on the Cadillac?
No.
Oh boy. Okay. Are you done yet?
Now it's a ball.
Now it's a
ball. Was that necessary?
Really?
I didn't say it. Are you kidding me? I didn't say it.
It sounded like you said it.
Emmett did.
Emmett.
Don't be a baby.
Yeah, good. Okay, in our formula we'll have a p. That distance there is p. No, I'm not ignoring Emmett's stupid comment and considering how to end him. That little distance right there is p, right? Like, focus. All right, that's the only one we need to worry about. Everything else, the vertex is hk, right? And everything else is based off of those values. Okay, so this value of p, your book writes the formula a little funny. Okay, it looks like this. This is what your book writes. Exactly. Okay. So I want to transfer it to this format because that's what we know, right? Okay, so I divide by 4p, correct? And add k. So y equals 1 over 4p x minus h squared plus k. They look pretty similar now, right? Yeah, so A is 1 over 4p. So that's how these two equations are related. So really not much new except you're learning the distance here between the focus and the vertex.
So A is 4p.
No, A is 1 over 4p.
How do you determine p?
The equation?
So you'll be given an equation such as this, and you can put, say this is 2. 2 equals 1 over 4p. Right? You could solve for p to find this distance. Or if you're given p, you can solve for a if you want to. Okay. So you can transfer between those two. P is useful because, again, it gives us that distance there. Okay, let's do an example. Oh, they're all sideways. Come on. Okay. Let me see if I assign
There's
it.
another one.
Sometimes it's necessary to complete the square. So let me see if I actually assigned it. Just to make sure. 6.
Did you hear that? Micah has crystal meth.
What?
Crystal meth.
Oop, there it is.
You want to see? It's right here. No, it's just a piece of glass.
Technically, you have.
No, it's not.
That's dangerous.
Okay. So
I know. We jump out of windows on boobs.
okay, so if we're to graph that function.
Hold on to your.
Okay, that's enough, children. So this is the format your book puts it in, obviously. If you were to graph that, what is the vertex of that parabola? Okay, is there a number with the x?
No.
Okay, so we know that the x is 0.
3.
Okay, and then the y value for the vertex is right there. See?
3.
Right, so it's going to be 3.
No.
Right, so we have a vertex. What is our value of p?
Negative 4 equals 1 over 4.
Right?
Right?
So this right here in our formula is 4p. So what does p have to equal?
1 over negative 4.
In this position, in the formula, if you look at the book formula, that value is 4p, right? So if I come back here, 4p equals negative 4, right? So what's p? Know when to use 1 over 4p and when to use 4p.
Not yet. Not exactly.
If the number is with the y, you have to use 4p. If it's over here with x squared, that's when it's 1 over 4p. Okay.
Oh.
So if we were to move this over here, it'd be divided by, right? So, okay, so p is negative 1, which means our focus. Okay, this is a vertical parabola, right? Opens up or down, one of the two. So we know that the focus is going to be above the center or below it.
Are you asking us?
Yeah, above or below. Yeah, it's below. This is actually, see the negative 4? That does tell us that this is a downward parabola. So the focus is down here. So the focus is 0, 2, because that is 3 minus 1. Right. So it's the y value minus the p, right? Or plus it, actually, it's just negative. So there's our focus. What about our directrix? Up here, right? It's an equation because the directrix is a line, so y equals three minus -1, which is 4. Right, so we're just playing with the p value. Right? This is the value of p. So we add, and since it's a negative, it drops it down. And this is the value of p as well, so we'd subtract it to get the directrix, but that ends up, of course, adding it. So y equals 4. What's the axis of symmetry? X equals 0. There you go. Matches up with the vertex x value. I'm waiting.
The focus, 0, 0, 2.
Yep.
Wouldn't it be negative 2?
No, my graph's not right. It's just an illustration of. Let's try this again. How about we just graph it for real, because we need to anyways. Whoa, that's not what I wanted. So the vertex is 0, 3, right? The focus is 0, 2. You get an F. The directrix, y equals 4. Right. And then the axis of symmetry is x equals 0. Boom. How do I know how wide that opens? We want to be precise. How do I know if I need to go out here or do I need to go down here? Yep. What's the best number to use? 0 for x or y? If you use 0 for x, we already have that.
Why?
Yeah, if you plug 0 in for y, you're going to get the roots of the equation, right? Oh.
Not x. Isn't it y up and down?
No, if I 0 on the y is right here,
Yeah.
it'll give me the x values that I need to find the roots, right? So x squared equals -4 times 0 minus 3. Positive or negative root 12. Anybody know what that is? That's a pretty good guess, I bet you. So somewhere in this range will be our roots, and then we can finish. Okay. So that's one way to do it.
Is there an easier way? Knowing calculus?
Well, what if I plug x equals 1 in? The answer is not always knowing calculus, although it is pretty handy most of the time. What do you get for your y value?
Go back to the thing.
X is 1.
1 equals -4 y minus.
So negative 1/4 plus 3, right?
Yeah.
2.75, 2 3/4. Right. So 1, 2 3/4 would be that point. Do I need the other one, or can I use symmetry? I can use symmetry to know that there's a mirror image. Okay. So there's another way to do it. If you think either one's easier, it doesn't matter to me. Cool. Parabola. That's we also want to consider the sideways version. Yeah, I know. Sucks, doesn't it?
What it is, like, in real life, what would be the sideways version used for?
Basically, it's wherever you want to position your parabola.
Like,
If you want your satellite dish to be vertical, probably not.
Like this.
Most of them are tilted, right? But if there, here's something really cool. I think it was a James Bond movie where they had the big solar power plant, and they focused all the solar panels into one spot, and it superheated water and made power in the desert. Was that a James Bond movie?
No, that's Sahara.
Oh, it was Sahara. That's right. So, anyways, one way to produce power is to have a parabolic mirror, and you have a focal point here. So the sunlight comes in and focuses all the energy of the sun right there. And there are different ways to do this, but you can use that energy to heat water and make steam, turns a turbine, generates power.
Solar.
Okay, so that's, I mean, vertical. You can do the same thing sideways. Okay, there's one power plant in the world that has mirrors. All the mirrors have to do is direct the sunlight to the parabola, because it's a mirror as well, and then it focuses all the sun rays in that one spot. Okay, so it's all about positioning. But that equation is very similar to this one right here. We just switched the x's and y's. We switch the x's, the h's, and the k's. No, they still pair up. Okay, thankfully. So, always keep the vertex values with the variable it matches. Okay, so. But again, your values for P is still the distance between focus vertex and directrix vertex. Okay, that's still P. It's the same drill except you're facing sideways. Let me show you an example.
Yes.
So in this situation, would you plug in 0 for x?
Yeah, that would give you your y-intercepts, right? Wrong button. Button. Let's try this. Is that in the format that we just saw? But can we make it that way?
Absolutely.
Okay, Kellen, educate us.
You subtract 48.
What's the answer? Use math. Congratulations. No.
No.
Let me give you a hint.
Oh, you factor.
Oh,
Factor out what?
back 4.
8. You factor out 8. 6.
Now does it look a little better?
A little bit.
Yeah. Now that's a format that the formula matches, right?
Yes.
So our vertex is -6, 0. Right, -6, 0. What's our value of p? Knowing that this is 4 p's.
2.
P is 2. Right, 2 times 4 is 8.
So if it's with if the P is with the X, it's 4P. If it's with the Y.
No, if it's with the singular variable, it's 4p. If it's with the squared,
Oh.
it's 1 over 4p.
Okay.
Right? I'll show you that.
No, I get it.
4p's with singular, 1 over 4p with squareds. Okay. All right, so we can start graphing this beast. Which way does that parabola face?
To the right. To the right.
Why?
Because it's positive.
Yeah, positive opens right. Okay, so our vertex is -6, 0. Our P is 2, so here's our focus at -4, 0. Our directrix, x equals -8.
Wait, why are you doing that?
Right, 2 and 2, right? Here's our
No,
vertex.
yeah, I got it.
2 and 2, focus directrix, and then how can we find another point?
Zero.
0 for x
Yes, please.
or y? We already have the 0 value for y, so if x is 0, we get $48.
Yeah. Right.
What's the square root of 48? Square root of 49.
6.9.
Yeah, you're pretty darn close to 7 there, right? So somewhere in there and there, and you get your okay. You can write that as a square root function too. How would I rewrite that as a square root? And I only say this because it's a skill that's pretty handy and it comes in useful. So y equals what?
Positive or negative 8x plus 30.
So if you're using parent functions here, how far left are we? 6 units. Right, and that square root of 8 is going to make us be bigger and open wider. And the negative's giving us the bottom there. Okay, so your parent function knowledge still applies if you rewrite it. It's a valid way to do that. Okay. All right. The usefulness of parabolas has been illustrated. Do you have any questions?
So like skateboarding, right?
Yes, it was a fantastic performance. Thank you. You're welcome.
Hey, it's like a skateboarding ramp.
Could be. Yep. Math can ruin everything. There you go. 10 problems have been going easy on you. Don't abuse that.